Hi everybody, this is Ravi. Last video we have discussed about the basis to design the chemical plant. If you didn't watch that video, please watch the video. Link is available in the description box. Before designing of a chemical plant, first we should understand the process. In that, first and foremost step is to understand the stoichiometry. Today we'll discuss about the importance of a stoichiometry in chemical industry. What is stoichiometry equation? In Greek's, measuring elements. So stoichiometry literally translated means the measuring of elements. Based on the textbook definition, the stoichiometry is the calculation of a quantities in a chemical equation. In given chemical reactions, stoichiometry tells us what quantity of each reactant we need in order to get enough of our desired product. Stoichiometry is the heart of the production of many things you use in your daily life. Importance of the stoichiometry for the chemical engineering. Stoichiometry is very important for chemical engineer to calculate the mass balance. By using stoichiometry, the chemical engineers can determine how much of each chemical they need to yield given amount of a product. And we can predict the outcomes. It is not always possible that A plus B forms C. There is a possibility of formation of a byproducts in the part of the reaction. Based on stoichiometry, we can predict the products, byproducts. We can calculate the amount of a products and byproduct formation. We'll come to know whether the byproducts are a gaseous, liquid, or a solid. In case byproduct is a gaseous, which gas is liberating, how many moles of gas is liberating in that. It will be helpful during scrubber calculations and vent size calculations. In case byproducts are liquids, as a chemical engineer, you should understand how to separate those liquids, either distillation or separation process. In case byproducts are solids, solids are soluble or insoluble. If solids are insoluble, we can separate through the filtration method. In case if solids are soluble with organic or aqueous, we can remove those byproducts during the separation stage. As a chemical engineer, you should understand what is limiting reagent, what is excess reagent, how many moles of excess reagents we are using in the process. Is there any possibility to reduce those excess reagents in the reaction? Basically, by using the stoichiometry, we can optimize the process. So here, based on the stoichiometry equation, we calculate mass balance, predicting of a product and byproduct details. It will be helpful during wind size calculation and scrubber calculations. Putting all the pieces together, writing equation from the words. For instance, sodium carbonate react with the aqueous HCl to form sodium chloride, water, and liberation of a CO2. This is the stoichiometry equation, but it is not balanced. We should balance the equation. Balancing of equation works on the law of conservation of mass. Mass of reactants is equal to mass of the products. So here 1 mole of a sodium carbonate is reacting with 2 moles of a aqueous HCl. It is forming 2 moles of sodium chloride, 1 mole of a water molecule, and 1 mole of a carbon dioxide gas. Based on the law of conservation of mass of reactants is equal to mass of product. Here in the chemical equation, 2 atoms of a sodium, 1 carbon atom, 3 atoms of a oxygen, 2 hydrogen atoms, and 2 chlorine atoms are present in before and after the reaction. The total mass after the reaction is the same as before the reaction, and the coefficient tells us how many moles of each. Thank you for watching video. If any queries or requirements, drop the message in comment box.